Good morning, students. We just started our fourth unit, sorting techniques, right? So we will first recall our last class and then we continue with today's class. So, what is sorting? The problem of arranging the elements in a particular order, either in ascending order or in a descending order. Any particular order, we call it as a sorting problem. So, mainly we are having two types of sorting problem. First one is internal sorting and another one is the external sorting. So the internal sorting which takes place only in our main memory, whereas external sorting which can be done in our the external hard disk or a tape, magnetic tape, right? So as far as our example is concerned, so internal sort, so all our discussion, bubble sort, quick sort, insertion sort, heap, radical selection, all comes under the internal sort, because all the sorting techniques which are carried out only in our main memory itself, right? The only example of our external sort is our external merge sort. So merge sort which will be done in our external memory, if our list is a bigger one, right? So there are two main criteria which will decide the efficiency of our algorithm we have just right. So the first one is time taken to execute the particular algorithm, and the second one is the space occupied by the particular algorithm. So these two, time complexity and space complexity, which decides the algorithm's efficiency, right? That we already know. So we already saw the bubble sort technique last week, last class. So what is a bubble sort? It is also a comparison based algorithm. It will compare the adjacent element, and if the adjacent element is smaller or it is greater than our previous element, then just we have a copy. So it is for every iteration of, for every pass of our I, it will moves into the largest element into its correct position, right? So from the right, it is going to place our algorithm. So this is our algorithm. This we already discussed in the last class. So we already saw one example also. Yes, you want go through this. So what are all the advantages and disadvantages of bubble sort? So it is simple to understand and simple to implement. Do not use extra memories, right? So what is the disadvantage? Because of its complexity, so the worst case and average case complexity, time complexity of this algorithm is big O of n square, right? So so this algorithm is not well suited for our array with large size, right? So that is the disadvantages of our bubble sort. So analysis, we already saw the time complexity of our algorithm is big worst case and average case is big O of n squared, and the best case complexity is big O of n, right? And the space complexity be big O of 1. So nothing will be needed except the array size, array element, the storage needed to store that array element, right? So that is big O of 1, the storage complexity, space complexity. So the application where the bubble sort is mainly used is in TV remote programming. They use bubble sort technique to sort the channels based on the longer viewing time, right? So that is one of the main application of our bubble sort. So now let us move on to the next. We are going to introduce the next sorting algorithm called as selection sort. Yes. So let us consider the selection sort. Selection sort is also one of the in-place comparison based algorithm only. But what is the difference between bubble sort and selection sort is that bubble sort is going to compare the adjacent elements, and if it finds the adjacent elements are when the previous element is bigger than our adjacent element, next adjacent element, it will swap, right? Here in the selection sort, we are going to first divide the array into two part. One is the sorted part and another one is the unsorted part, right? Initially the sorted element array is empty, and the whole list is going to be considered as an unsorted one, right? After every pass, the leftmost element, that is the least element in the array, is provided in our first position. That is correct position, right? In bubble sort, we are moving the largest element to the end of the list. Here in the selection sort, based upon the minimum element, we are going to fix the minimum element in its correct position in every pass from the unsorted part of our array, right? So that is the concept here. So let us consider how the selection sort works. So here is we are having, first we have to consider the first element as the minimum element in our array. So that is the index 0. The element present in index 0 is considered to be a minimum element. We are going to compare the other n minus 1 elements with that minimum position element. So index 0 is compared with all the n minus 1 elements, but if we find any element lesser than our min element, then we are going to change the min position to that position j, right? So and then we have to check with that minimum element, we are going to check with the remaining array unsorted elements. If we find the next element, we are going to change the min position, and finally we are going to swap the min with that corresponding j, right? So we will see our algorithm, then only you will get better. So this process will be continued until all the elements in the array are sorted and the unsorted element of array part becomes empty. Okay. And all the elements are get moved into our sorted part of array. So let us consider this is a algorithm pseudocode for our algorithm code for our selection sort. So here I am going to, for all the sorting technique, we are going to pass an array and its size, right? Because while passing an array as a function argument, we have to pass the array name as well as the size of that array, right? So for each and every array, we are passing as an argument to our function. So we have to pass two arguments. One is the array name and another one is the array size. Yes. So here I am using array. Here I am using array. Array size, array name as int array, and size as int size, right? So here we are having two elements. Yes. Then we are having, I'm using so algorithm, they are given as position, but we are going to point out the minimum value there. So I'm using it as a min variable, right? So we have to declare the necessary variables for this function selection sort. So I'm declaring we are going to use two loops. So for two loop induction variable, I am using I and j variable, and then for pointing out the minimum position where it is where the minimum element is present in the next minimum element is present in the array, I am using the element variable called minimum. Then we are using for temporary swapping purpose, I am having a temporary variable, right? So for I is equal to 0, I is less than or equal to n minus 1, I plus plus, we are going to first assign, we are going to, so as we told, first we are going to consider the minimum value as I, right? What is I? Now the I value is 0, right? I is initialized with 0. So the index 0 we consider as a minimum element position initially, right? And then I am going to set up my j loop. J is less than or equal to j is equal to I plus 1. So our ith position value that we consider as a minimum value. So from the next position onwards, we are going to check. So I am considering my j value from I plus 1 and j less than and j plus plus, right? So if we are going to check if a of min, the index pointed by the min value element and the j element, if min is greater than a of j, then we are going to modify the min position index as j index. Yes. So this similarly it will goes upon after the j iteration completed, it comes out of the j loop, and we are going to check one condition whether min is not equal to I. If min is what is the mean by what is first we are initialized min value with I, right? What is the meaning if min is not equal to I? Meaning that the index position, we are first initially consider the ith position value, that is index 0 value is the minimum value in our array. But if the minimum element is present somewhere in the array, we are replacing that min position by j, right? So if any changes occur, we have to swap that first element with that jth element, right? So for that only we are going to check If min value is not equal to j, then we are going to swap the values, right? So temporary is equal to a of I. I am assigning a of i's value. What is a of I? So for currently I value is 0. So zeroth index element is going to be stored in temp, and then zeroth element, we are assigning zeroth element with a of min position. So now min position value is changed with current j, not current j, the j having the minimum element, right? So current j is not equal to min, because j gets incremented up to 7, right, up to 8. So j value is 8 now. So at last j value is 8, that is not equal to our min. So for that purpose only we are assigning one, whenever we are identify the minimum value present in our j, we are assigning that jth position to our min. Yes, understand? Then a of I is equal to a of min, and a of min is equal to temp. This swapping concept you already know. So we have swapped the values, right? Yes. So now we are having, now we consider our example. Now consider an example and we walk through this algorithm. So consider the following array. I am having a set of elements 14, 33, 27, 10, 35, 19, 42 and 44. So I am having 1, 2, 3, 4, 5, 6, 7, 8 elements. So my n value is 8, right? So we will walk through this algorithm. So first iteration of I begins, right? So I begins. So what is I value? So I value we are considering it as I is equal to 0, I is less than or equal to n minus 1, I plus plus. So initially I gets initialized with 0. Then n is equal to 8, right? I is less than n minus 1 we are checking. So n minus 1 we are 7. So 0 less than 7 we are checking as the condition is true. So it goes inside the I loop, right? And assigning min is equal to I. What's the value of I? I value is 0. So min value is also 0 then. Yes. Then j is equal to 1. So j loops gets initialized, right? So how we are initializing our j loop? J is equal to I plus 1. So current value of I is 0. So 0 plus 1, the j value gets initialized with 1. So j value is equal to 1. 1 is less than or equal to 8 we are checking, because we are checking the j loop against n. Yes, so not n minus 1, it is against n. So 1 is less than 8 we are checking as a condition is true. So we goes inside the loop and we are going to check. What we are going to check in that if condition, a of min is greater than a of j. Current min value is a of 0 and a j value is a of 1. Right, we are going to check a of 0 and a of 1. So 14 is greater than 33, we are going to check. The condition is false. So because the condition is false, it doesn't execute that min is equal to j instruction. So the j loop gets exited. So next iteration of j begins. So j value gets incremented. Now the j value becomes 2. 2 less than a, the condition is true. Yes. So now the min value doesn't change yet. So the min value is same 0, right? So min value is 0, but j value is 2. So a of 0 is greater than a of 2, we are checking. So now 14 is greater than 27. The condition again becomes false. So next j value gets incremented. Now j value becomes 3. Yes. So j value becomes 3. So j value is 3 is less than 8. We are checking the condition is true. Again we are checking a of 0 is greater than a of 3. So because the minimum value is doesn't change, right? So 14 greater than 10 it is checking. Right, the elements are initially the elements are 14, 33, 10, right? Okay, 14, 33 and 10 initially, right? Sorry, 14, 33, 27, 10 and 35, right? So now this is 0th index 1, 2, 3. We are checking 1 and 2. Now the j value is 3 now, right? So a of 0 is greater than a of 3. We are checking. 14 is greater than 10. We are checking. As a condition becomes true now. So if it is getting true, it is going to execute this min is equal to j instruction. So min is equal to j, which j value is now 3. So minimum value is changed as 3 now, right? So next the j value is incremented. So now min value is 3 and j value is 4. We are checking a of 3 and a of 4. A of 3 contain 10 and a of 4 contain 35. We are checking. So up to j value becomes 7, it will goes up. When once j value becomes 8 is less than 8, the condition becomes false and j loop gets exited, and we are having the swapping part, right? So if min not equal to j, what is our current value of min? We are changing min value as 3 in the middle, right? So now the min value is 3 and as it is not equal to 0 because current I value is 0, right? So this condition becomes true. So swapping occurs. So the swapping takes place, and 10 is moved into the first index position, and the 10th position, the position where 10 is in the array, 14 is moved over there. That is a of 3 position 14 will be moved, and a of 0 position the 10 value will be shifted, right? So after the first pass, the elements are 10, 33, 27, 14, 35, 19, 42 and 44. Similarly, for 7 iterations of for remaining 6 iterations for I will be conducted, and finally the elements are sorted, right? Here is our full pass. So after first pass, 10 will be moved into R. So after the first pass, 10 is moved into the correct location in this ordered array, right? So after this, so 14 is here. So next minimum element consider as I. So I is 1 now. So 33 is considered as minimum element. It will be checked with 27 and then at 14. So if we are checking, the minimum element is 14. So minimum position is changed as A of 3 now again. So 14 is checked with remaining all elements. No other elements are smaller than 14. So 14 is moved with A of I and minimum positions are interchanged. And 14 will be fixed in its correct position. Similarly, all the elements are swapped, and after pass 7, all the elements are get sorted in correct position order. Yes, understand? If any doubt, message me in our group or call me. I will clarify your doubts, right? Then we are having our advantages of selection sort. It is also well performed for a simple small list, and it is an in place comparison based algorithm. So it doesn't require any extra storage or a temporary storage to hold its original to no other temporary storage is required for performing the sorting, right? So only what is required to hold the original list is the required one. Then we are having the primary. The disadvantage of this is also not well performed when the list size is bigger, right? Because it will require n square steps to perform a given input size as n, right? So the best case and worst case time complexity of our selection set algorithm is big O of n square, and average case is big theta of n square, and best case is big gamma omega of n square, right? And then space complexity, it is 0 of 1 because nothing will be needed, right? So big O of 1. So applications, selecting particular item from the list, particular item, choosing a particular item, and then placing picking a fresh fruit from a basket. So these are some of the real-time examples of our selection sort algorithm, right guys? Okay, you will all understand, I think so. If we are having any doubt, go through this. If you have any doubt, just call me. I will clarify it. Thank you. I will also give you the visualization video also. You will also go through that.